All right, guys, so what we're starting today is Chapter 9. So Chapter 9 is dealing, well, triangles. And as you've noticed, triangles show up again and again and again and again. Triangles are one of the most useful shapes in geometry. There's actually an entire topic called trigonometry, which is really focusing around triangles. It's all focused on triangles. And sine, cosine, and tangent is part of trigonometry, solving for missing sides and angles. Now, before we delve too deeply into sine, cosine, and tangent, we're going to talk about right triangles to start with, and then we'll talk about some non-right triangles later on. And the first kind of theorem that we come across is the Pythagorean theorem. The Pythagorean theorem states in a right triangle, the square of the legs of the hypotenuse, the square of the length of the hypotenuse is equal to the sum of the square of the legs, length of the legs. Or, as I think most of y'all know it as what? Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs of the triangle, and c is the hypotenuse. Now, Pythagoras is the one that this is kind of known for. It's not actually stated for sure that he is actually the first one to come up with this. The Egyptians actually had this theorem, and were able to use this with lengths of rope, that they were actually to get a length of rope with 3 knots in the segments of 3, 4, 5, or these kind of lengths, and they could actually create a triangle using it. Because what they would do is they would actually take this rope in these segments, put a stake here, and if they brought this back around, let's see here, stake here, brought it down here for 4, and then back, it would end up making a triangle, and they can use posts to actually create this. Mr. McClendon, I do. Okay. Bye. Your glasses are here. And I mean, we could do this here. Now, the Egyptians and Babylonians actually came up and used this theorem or knew about these numbers quite a long time before the Greeks. So, but Pythagoras was one that actually, for some reason, made it popular. I don't know why. He just did. Pythagoras is a weird and interesting kind of person. There's not a whole lot known about Pythagoras. And a lot of it, it's referenced in different articles and different sources. Different people have referenced him: Socrates, Plato, Aristotle. If you've ever heard of those 3 guys, they're pretty famous-ish. Talk about him, and different Greek writers talk about Pythagoras. And I mean, it's weird and far between. Some reference him to almost a god of some sorts, that he was this divine being. Some references have him talking to animals, like conversing with cats and dogs. So it's, and some say, and he actually did form a cult of sorts, the Pythagorean cult. And it wasn't like you would think of as a cult and whatnot. They actually worked together to research mathematical ideas in geometry and different forms of numbers and different types, and worked on this stuff. And they came up with a lot of interesting things. Some say that he didn't actually come up with any of it. It was more the members of his society came up with a lot of it, and then they gave him credit for it because he was ahead of it. Now, they were very secretive in what they did. They didn't really like a lot of stuff getting let out. They had one guy talking about what they had been kind of looking into and researching about what we call irrational numbers, a number that's a non-repeating, non-terminating decimal, and was talking about that there. Well, after he had let that slip for some reason, he died from falling off the side of a ship and drowning by accident. So they really didn't like things getting out. So there's a lot of stuff around Pythagoras that's interesting, but most of what we know is lost. We don't have any real documentations of what he actually did. It's all secondhand and speculation. But the theorem, a squared plus b squared equals c squared, is what we call the Pythagorean theorem. And it solves for any side. We can, if we have 2 sides of a right triangle, we can solve for the third by using this theorem here. Now we have some special ones here: 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. These are some of the most common ones, and we can have different multiples of them. You don't have to write these down. But these are different multiples of the same thing. Because if we look at 3, 4, 5, well, 6, 8, 10, because I just took 3, 4, 5 and multiplied them all by 2. 9, 12, 15, well, I took those same numbers and multiplied them by 3, and going on. Now, these here are what we call Pythagorean triples. And what that means is these three numbers, if you plug them into the Pythagorean theorem, it works. A Pythagorean triple is three numbers whose, when you plug them into the Pythagorean triple, will work. Three whole numbers that work in the Pythagorean theorem are considered a Pythagorean triple. Now, these are just a few. There are many, many, many different Pythagorean triples. Now, it'd be kind of interesting, well, how did they find these, right? It'd be kind of interesting to kind of see, well, where in the heck did they come from, right? Some of them were known, again, that the Babylonians knew about 15. Babylonians and Egyptians, so one of those two knew about 15 of them total, unique ones. And then Euclid, I think you probably heard his name, yes? Euclid, because that's what we're covering this entire year is Euclidean geometry. And in Euclid, in his book, number 10, postulate or proposition 29, lemma 1, states, as long as we have a value of m and m is greater than n, then 2mn, m squared minus n squared, and m squared plus n squared will always generate a Pythagorean triple for any values of n and m, as long as m is greater than n. Okay, that seems like a weird statement. 2mn, m squared minus n squared, and m squared plus n squared. Well, the one Pythagorean triple we know for sure is 3, 4, 5. It's one of the most common ones we use. So if I look at this here and I say m is 2 and n is 1, well, this here would be 2 times 1. That would be 4. Yes? Okay, the next one would be 2 squared minus 1 squared. 2 squared is? 4 minus 1 is? 3, yes? And the last one is just going to be 2 squared plus 1 squared. Well, that'd be 4 plus 1, which is 5. 3, 4, 5. And again, this works for any values of m and n as long as m is greater than n. And this is something that Euclid came up with and found. And really from here, we can generate any Pythagorean triplet given any values of m and n. But that's just what a Pythagorean triple is. As long as we have three whole numbers, we don't have any decimals, they are going to be considered a Pythagorean. As long as there's no irrational, they're going to be considered a Pythagorean triple. And they're integers, so no decimals, no fractions, whole numbers. Okay, let's use the Pythagorean theorem on this here. Find the value of x and tell whether the side lengths form Pythagorean triple. So our formula, a squared plus b squared equals c squared. So what am I going to plug in for a, b, and c? Yeah, we can call it c x squared or c squared. It doesn't matter which because it's still just a variable that we'll be solving for. Well, what can we do next? We can do 12 squared plus 5 squared, yes? We can type that in a calculator. Now, 12 squared is 144. 5 squared is 25. So we get this here. Now 144 plus 25, if we add those together, we're going to get 169. Yes, because once we add them together, we square root it because I want to know the value of x, not the value of x squared. Now x is equal to what? Plus or minus 13. The square root of 169 is plus or minus 13. Why do we say plus or minus? What's negative 13 times negative 13? 169, and would it be positive? Yeah, because a negative times a negative is a. Now, positive 13 times positive 13 would still give us positive 169, yes? So really, whenever we take the square root of both sides, we have to put plus or minus, because that link could be a negative and a negative, which would give us the positive, or two positives. But why would I not consider the negative case, this here? Why would we not need the negative? Right, we're talking about what? We're talking about the side length of a triangle. We don't talk about distance in negative units. So even though technically it would be plus or minus 13, we just have that the hypotenuse of this is 13. Now, would this be a Pythagorean triple? Yes, because all three numbers are integers. No fractions or decimals. So yes, this would be a Pythagorean triple. A squared plus B squared equals C squared. And we're given the side lengths of 4, 5, and X. So what would be the values of A and B? So what do we have? Equals X squared or C squared, either one. Well, first we need to simplify because we have 4 squared and 5 squared on the same side, yes? So we can plug those in a calculator. Now 4 squared would be 16. 5 squared would be 25. 25 plus 16 is going to be 41. And what do we have to do next? Now the square root of 41 is the square root of 41. There's no perfect squares as factors. 41 does not have a perfect square factor. There's not a number that times itself will go into 41. So 4 squared. So 4 is not, because 4 is a perfect square, it doesn't go into 41. The next one after that would be 9, 16, 25. None of these are factors of 41. So that's as simplified as it gets without turning it into an irrational decimal. Now, is this a Pythagorean triple? No, because the square root of 41 is not an integer. It's an irrational number. So that would be no, this is not a Pythagorean triple. Questions on this here? Are we good with these here? Okay. Okay, let's look at this one here. So again, we're solving for the side lengths and determining whether it's a Pythagorean triple. So what's the values of A and B? So 7 squared plus 14 squared? So the A and B are the legs, yes? What are our legs? 7 and? The hypotenuse is 14 squared. The hypotenuse is always opposite the right angle. The hypotenuse is always opposite the right angle. So in this case, it would be 14. So this one here, we're going to have to do a little bit more math. We'll have to do a little bit more to solve this. Now we can simplify this here. 7 squared is 49. X squared is still x squared. And 14 squared is 196. Why does that seem so big? I think it's 156. I feel like 196 is too big. Okay. Sounds good. Now, what do we need to do next? We need to minus 49 from both sides. $147. And then last but not least, we would square root both sides. And when we square root both sides, so the TI 30xs will simplify these radicals for us. 7 square root of 3. I have a feeling that the big ideas math will also take square root of 147. Okay. Now is this Pythagorean triple? No, because we have the radical. So it's not a Pythagorean triple. Okay. Let's look at this one here. All right. So when we look at this here again, we're sticking with a squared plus b squared equals c squared again. Now our legs for this here, a and b, are going to be what? So 15 squared plus x squared equals 25 squared. Now this time we just can't plug everything as a calculator. We've got to do it individually. So we'll have to do 15 squared, which is 225. I want to say 675. 625. Is going to be 25 squared. So we plug those in, 15 squared and 25 squared. Now again, we want to get x by itself, so the first thing we can do, the next thing we can do is to subtract 225 from both sides, because we need to get x by itself. These will cancel. And that leaves us with what? X squared. And we need to square root x squared and 400. Well, square root of x squared is x, and square root of 400 is 20. Is this a Pythagorean triple? Well, yes, because we have 3 whole numbers, don't we? Questions on this here? Are we good with this here? Yes? Okay. I feel like we're pretty good with these Pythagorean triples, yes? Or solving for the missing side and determining if it's a Pythagorean triple. All right, let's solve one real-life problem, and then we'll move on to the next thing. So when I look at this here, I want to know the skyscrapers are shown are connected by a skywalk with support beams. Use the Pythagorean theorem to approximate the length of each support beam. So, well, we're going to have a squared plus b squared equals. So what values do we know for sure? Is? So we can plug it in as one of the legs. So we can say it's A. So we have 47.57 is the other leg. And the hypotenuse is what we're looking for. So 47.57 squared plus 23.26 squared is going to give us what? Well, at this point here, we can just type this into the calculator, yes? Because two numbers, they work together. And we get well, guess what we're going to have to do? We have to take the square root of 2,262 and 949 ten-thousandths. And if we do this here, what would we get? And 9325? And what do we do if we get the square root? Or what do we get when we take the square root? Hmm. 52.9 what? Or we can say it's approximately 52.95 if we were going to two decimal places. And that's it, because we're doing the same thing. It's just now we have some decimal numbers to work with. So, and that's it. It's just using the same exact thing to find the third side of a right triangle. So we can use a squared plus b squared to find the missing side of a triangle. Now, the converse of the Pythagorean theorem states if the square of the length of the longest side of a triangle is equal to the sum of the square of the lengths of the other two sides, then it is a right triangle. Well, the only time we can use the Pythagorean theorem is if it's a right triangle. Now, if the Pythagorean theorem is true, if a squared plus b squared equals c squared, then it's a right triangle, because this only works if it is a right triangle. So what that means is we can take a triangle like this here that has side lengths 8, 7, and the square root of 113, and we can figure out if it is a right triangle. Now, C is the hypotenuse. The hypotenuse is always the longest side. Now, what's going to be the longest side for this triangle? Because what is the square root of 113? What was the first number? 10. So if we turn this into a decimal, we get 10 point something. So it's telling us that this is the biggest side. So sometimes we need to check to see which side is the biggest side. So this tells us that the square root of 113 would be our hypotenuse. So to determine if it's a right triangle, we're going to use a squared plus b squared and find out c. Now, if these are equal, then it is a right triangle. If they are not equal, then it will not be a right triangle. And we can plug in A and B and plug in C and see if these are equal. So the first thing we can do is 8 squared plus 7 squared. 8 squared plus 7 squared. Well, 8 squared is 64. 7 squared is 49. And if we add these together, we get 113. Now, the square root of 113 squared is, well, 113. So are these equal? So is this a right triangle? Yes. Since the sum of the square of the two legs is equal to the hypotenuse, this is a right triangle. And that's it. So look at this one here. Now it does work out 4 square root of 95 is bigger than 36. 4 square root of 95 is the hypotenuse. Huh? So that makes this here our hypotenuse. So to see if this is a right triangle, well, we can do 36 squared plus 15 squared and see how it relates to 4 square root of 95 squared. Now again, we could type this straight into the calculator. You can type in 36 squared plus 15 squared, and it would give you a number. And that number would be and we can do the same thing with 4 square root of 95. Now again, when you type in 4 square root of 95 squared, you've got to make sure that there are parentheses around the 4 and the square root of 95. And if we type this in, we will get 1520. So are these equal? Are these equal to each other? Well, no. One's 1,521, the other is 1,520. So since they're not equal, is this a right triangle? No. For this to be a right triangle, they have to be equal. For this to be a right triangle, these two have to be equal. Eight point nine four four two seven one nine one. So it works out here, this 4 square root of 5 is not the biggest side. So we can't just say because it has a square root, it's going to automatically be the biggest side. This time it is 12. So to work this out, we need to see if 8 squared plus 4 square root of 5 squared is equal to 12 squared. And again, we can just type these into a calculator. We can do 8 squared plus 4 square root of 5 squared. Well, 8 squared is 64. 4 square root of 5, 16, 3, 80. And 12 squared is 144. And this here would give us 144. So these two are equal. So this means it is a right triangle. It works. Any questions on any of this here so far? Now I know you all have seen right triangles before you've done these, or solving the Pythagorean theorem, a squared plus b squared equals c squared. I believe you did it in 8th grade, or you did it in Algebra 1 a little bit. Yeah, you should have seen this at least once before. And I feel like we're good with this here. Yes, figuring out if it's a right triangle. Okay, last thing we're going to talk about today. For any triangle, ABC, where C is the length of the longest side, the following statements are true. If C squared is greater than A squared plus B squared, so if AC squared is less than A squared plus B squared, then the triangle is acute. If c squared is greater than a squared plus b squared, then the triangle is obtuse. So if c squared is greater than a squared plus b squared, then it's obtuse. If c squared is less than a squared plus b squared, then it is acute. So kind of from that logic, what would we say if c squared is equal to a squared plus b squared? It's a right triangle. Well, that's actually what we were just doing a minute ago, right? Because if a squared plus b squared equals c squared, then it is a right triangle. So here, looking at the longest side, if it's bigger than a squared plus b squared, then it's obtuse. If it is less than a squared plus b squared, then it is acute. Can we say anything of what the actual angle is? Well, no, we don't have any way of finding it yet. Yeah. Okay, we'll look at two of these here. So our first one that we're going to look at is this here. Verify the segments with length of 4.3, 5.2, and 6.1 feet form a triangle. And is the triangle acute, right, or obtuse? Now, this first part, verifying that it is a triangle, is something that we did previously. We did this last semester. And the way that we know it's a triangle is, well, if any two lengths added together will be greater than the third. So if we look at this here, well, 4.3 plus 5.2, I'm just picking the first two. If we add these together, 9.5, is that bigger than the other side? Well, yes. So I'm going to do 4.3 plus 6.1. Well, that'll be 10.4. Is that bigger than the other side? Well, yeah, the other side is 5.2. And lastly, we would have 6.1 plus 4.3, which would give us, I did the same one again. It's like, wow, it's interesting. Two of them came out to be the same thing. 5.2 and 6.1. Is this going to be greater than 4.3? Well, yeah, they're both bigger than 4.3. It's going to have to be bigger. And if we add them together, we get 11.3. So what all this tells me is that, well, yes, it is a triangle. Now we need to determine if it's right, acute, or obtuse. So what's C going to be? This is our C. Now A and B are going to be 4.3 and 5.2. And at this point here, we need to plug it in. We just need to plug it into the calculator. .1 squared, if we type it in, is going to be 37.21. Bless you. Bless you. So 4.3 squared plus 5.2 squared give us 31.36. So is C greater than a squared plus b squared, equal to a squared plus b squared, or less than it? Greater. C is bigger, yes? So if C is bigger, is it acute, right, or obtuse? Obtuse. Obtuse. Since C squared is bigger, it is obtuse. That's it. That's all we have to do for this here. Questions on this here? Let's look at this one here, the last one we're going to look at. Now, when we check to see if it's a triangle, do I need to do all three, adding two side lengths together to see if it's bigger than the third? We only have to do one. 3 plus 4 is 7. So it works, yes? Because if I do the other two, well, anything I add to 6 would be bigger than the other side, because 3 plus 6 is going to be bigger than 4, yes? Because 6 is already greater than 4. 6 plus 4 is going to be greater than 3 because, well, both 6 and 4 are bigger than 3, yes? So we really just need to look at the two smaller lengths. Do they equal bigger than the biggest? Okay. So 6 is the value of C. 3 and 4 would be A and B because they're the other two links. Now 6 squared would be what? 3 squared plus 4 squared is 25. Which one's bigger? So this here would be obtuse. Yes. Any other questions on this here? Are we good with this here? Yes? Okay. Now, it's not always going to work out that they're going to be obtuse. It's just these two worked out that way. We have some other ones in this note sheet that would be acute or right. But we'll stop here because I feel like most of y'all have got the hang of this. Yes? Okay.